Next up, I'm going to show you how to solve the ALEKS problem, identify the intermolecular forces. So what ALEKS is going to do here is it's going to show us a compound, and it wants us to identify what intermolecular forces are taking place within that set compound. And it wants us to pretty much check a box for each of the forces. Now, my tricks that I had to solve this one is fairly simple. So as mentioned before, always refresh yourself on intermolecular forces from Gen Chem 2. I'm not going to go too deep in the weeds on those. And no matter what, always check van der Waals. So looking at these three, no matter where van der Waals is, you're always going to check van der Waals, because at some point, one side of the atom is going to have the kind of a negative and a positive side to it, no matter what. Next, we look for polarity. Again, when we have polarity, which is a difference of 0.5 in the two electronegativity values, then it's going to be dipole-dipole. And then at the end, you want to do one final check just to see if you have a hydrogen attached onto an oxygen, nitrogen, or fluorine. And then that's really the only tips. We can kind of ignore this bottom one right here. But let's look at the compound. So I follow my first rule. I see van der Waals, so I'm always going to make sure that that's highlighted. And then I see that I have a nitrogen and it's attached onto carbon, so it is polar, so it'll be dipole-dipole. But I see that I don't have a hydrogen attached onto the nitrogen, so it'll only be these two. Next, I'll see what I have here, which is pretty much carbons attached to CH3s, carbons attached to CH3s. So that is non-polar, but I'm still following my rules and only really just check van der Waals, because again, no matter what, they're going to be van der Waals forces. So because I don't have polarity, it's not going to be dipole-dipole, and no oxygen, nitrogen, or fluorine present, so it's not going to be hydrogen bonding. And then at the end, I have this compound, and of course, I follow my rule. I'm going to check van der Waals. I'm going to see if I have polarity, so I have oxygen and carbon, which is a difference of 0.5 or higher for electronegativity. So I'm going to put dipole-dipole, and then the last thing, I'm going to check to see if I have a hydrogen attached on to a oxygen, nitrogen, or fluorine, and I have a oxygen right here that's attached to a hydrogen. So I'm going to just go ahead and put hydrogen bond in there. So again, fairly simple. Just refresh yourself on intermolecular forces from Gen Chem 2, follow the tips, and then you'll be good to go for this question. Again, if this helped you or your classmates, feel free to like, share, and subscribe to my channel. Thank you.